Okay, we are on 7.4 AP Calculus. This is part 2, and we are just solving some initial value problems. And this one's a little bit trickier than the first 3 that we did, in that I want to get my y's grouped on the left, my x's grouped on the right. Easy enough, multiply over dx. But I've got this term right here to deal with. I'm going to rewrite this as dy dx is cosine x e to the y times e to the sine of x. Now that's a property of algebra we should be okay with. X to the 2 plus 3 equals x to the 5th. So e to the y plus sine equals e to the y times e to the sine. This is also x to the 2nd times x to the 3rd. So those properties allow me to do this. Group my y's, 1 on e to the y, dy. Group my x's, cosine of x, e to the sine of x, dx. Integrate both sides. Well, I could treat this as integral e to the negative y dy here, dy. And this I might want to go u is sine of x, du is cosine of x, dx. And this is as simple as this looks, e to the u. And du takes care of everything else. So I get e to the negative y. Got a little chain rule there. Let's check in reverse. Does the derivative of this give me that? Yep, it gives me e to the negative y times the inside derivative. So that's good. Equals integral of e to the u wants to be e to the u. So that's e to the sine of x and plus c. So at this point, when I put in 0 for y, I get negative e to the 0th equals e to the 0th plus c, or negative 1 equals 1 plus c. Therefore, c is negative 2. So I come back up to here. Negative e to the negative y equals e to the sine of x minus 2, or e to the negative y equals negative e to the sine of x plus 2. If I take the ln of both sides, I get negative y equals ln. I'm going to write that as 2 minus e to the sine of x, and y is negative ln 2 minus e to the sine of x. So a little bit going on in that one, but nothing that we haven't seen in some form or the other. Okay, let's take a look at e. I'm going to group my y's. I'm going to get 1 on y squared. You might want to just write that over here as y to the negative 2nd dy equals negative 2x dx. Integrate to eliminate the dy and the dx. If this was y to the negative 2nd, I would get y to the negative 1st on negative 1. Let's check, find the derivative. I would get y to the negative 2nd, times negative 1, negatives cancel, so we're in good shape there. Equals integral of this, negative 2x squared on 2 plus c, or I get negative y to the negative 1st equals negative x squared plus c. Let's find our initial values. When y is 1/4, I get negative flipped 4 equals x is 1. I get negative 1 squared plus c. So I add 1 to both sides. I get c is negative 3. So I'm back up to here, and I've got, now how do I want to do this? Let's go ahead and just make this negative 1 on y equals negative x squared minus 3. Or y is negative x squared, multiply both sides by y, divide both sides by, try this again. I'm going to cross multiply here, so I get negative 1, I'm going to do this in 2 steps. I was going to do it in 1, but I think it'll be easier to see what's going on in 2 steps. Y times negative x squared minus 3, divide both sides, and I get 1 on x squared plus 3 is my final value for y. Can I choose any value here I want for x? Yes, so this is valid on all real numbers. Okay, let's take a look at just a couple of word problems here that really have the feel of things that we've done before. Suppose that a cholera bacterial in a colony grows unchecked according to a law of exponential change. Exponential change, I like it in this form. Amount at time t equals initial amount. You can write it with the y as the book has, and then that's going to be e to the kt. That's our formula, whether it's the book would show y equals y naught, that's fine. The colony starts with 1 bacterium and doubles in number every half hour. So I could put a half in here for t and 1 in here for a naught, but I also could say, well, if it doubles every 4 hours and it started with 1, or doubles, excuse me, every half hour, that means in a full hour it would double twice, we'd end up with 4. Either way we can get there. If you want to put 2 here and put a half there for t, we're going to get there. Therefore, t is 1, so now we are just 4 equals e to the k. Therefore, ln both sides, ln 4 is k. And our formula now becomes amount at time t equals initial amount e to the ln 4 times t. And our t is being measured in hours. How many bacteria will the colony contain? Oh, this is going to be a big number. So amount after 24 hours equals our initial amount 1 e to the 24 ln 4. So let's go ahead and take a look at that real quickly here. Get it where we can see everything. So I've got e to the 24 ln 4. And I get 2.8-ish. Let's see what the book has. General rule of thumb would be 3 decimals even on this rounding. So I'm going to jot that one down. We've got 2.815 times 10 to the 14th. How many bacteria? So there we have it. Doesn't even feel like a calculus problem. Okay, the decay equation for radon 222 is known to be this with t in days. About how long will it take the amount of radon in a sealed sample of air to decay to 90% of its original value? So they're not telling me like how many grams or whatever it is we have. We just want 90% of. So a sneaky way to do that is just to say, if I'm using amount at time t equals initial amount e to the kt, amount at time t, we could just say that's 0.9, or we could say this is 90 and this is 100. I'm going to say this is 0.9. That's 90% if I start with 1. And that is e to the negative 0.18 t. Wow, that's pretty easy for a calculus problem considering you've done this stuff before. So if I go ln both sides, ln 0.9 equals negative 0.18 t. So t is ln 0.9 on negative 0.18. So let's take a look at that. I get ln 0.9 divided by negative 0.18. And I get 0.585. T is approximately 0.585. And what are we dealing with? Days. Didn't take too long to grow, or for that to shrink down to, I guess it only shrunk down to 90%. I was kind of thinking along the lines, didn't take too long for that to get huge, but took a little while, took half a day for this to shrink by 10%. Okay, there's a look at your assignment, and good luck.